In this video, we'll start to look at a type of analysis called analysis of variance, or ANOVA, and we'll start to build an intuition about how ANOVA works. ANOVA is a technique that is used when comparing multiple populations with one quantitative variable. Let's look at an example. Researchers have wondered whether physical handicaps affect people's perceptions of employment qualifications. In one study, the researchers prepared videotaped job interviews using the same actors and script each time. The only difference was that the job applicant appeared with different handicaps: leg amputation, crutches, hearing impairment, or wheelchair confinement. 70 people were randomly assigned to view one of the videotapes, and then they were asked to rate the candidate's qualifications on a 1 to 10 scale, with higher scores indicating they felt the candidate was more qualified. So the parameters we're interested in are the mean score for all people with no physical handicap, which we can write as mu sub none, and then the mean scores for each of the other groups. And to investigate these parameters, we can look at the corresponding statistics. And our null hypothesis is that the physical handicaps don't affect perceptions, so all of these mean scores should be the same. So here are the actual mean scores for each group in the sample. It looks like having crutches led to higher ratings, and being hard of hearing led to lower ratings. But is this difference significant? Let's start by looking at a graph. Here is a graph of the mean scores. There appears to be quite a bit of variation between these sample means. And the dot for having crutches looks like it's higher than the others. But let's also think about the amount of variation within each group. The length of these bars corresponds to 2 standard errors above or below the mean, roughly the width of a 95% confidence interval. That is, these bars represent how much variation we'd expect to see from sample to sample within each population. And it looks like there is quite a bit of variation. For example, these suggest that the population mean for the hearing group might be as large as this, which is larger than the bottom of the interval for the crutches group. So it doesn't look like these data would be strong evidence against our null hypothesis. Now, what if our data had looked a little different? What if the error bars had only been this long? Now it looks like the population means might not have the same value in some cases, although there might be some overlap in some other cases. So here it looks like the population means might not all be the same as each other. That is, it seems like we might have strong evidence against our null hypothesis. So let's take a step back and think about how we were making these inferences. There are 2 types of variation we're seeing here. One is the variation between the sample means, which we can see as the amount of variation in the vertical position of the blue dots on the graph. The other type of variation is the variation within each group, which we can see as the amount by which the parameter might vary from the observed sample mean. And what we've done is to compare these 2 types of variation. That is, we looked at the ratio of the variation between the means to the variation within each group. And when this ratio is large, it is evidence that the population means are not all equal. So in the example here, when we looked at the amount of variation between the means and the variation within each group and compared these amounts, the variation between was larger, and we had evidence that the population means were not all equal. In contrast, in our original example, when we looked at the amount of variation between the sample means and the amount of variation within the groups, then this ratio was relatively small, so it was not evidence against the null hypothesis. So this is the intuition behind making an inference for comparing multiple population means. What we need is a new type of statistic that lets us formalize this comparison, and we'll look at how to do that in the next video.